Time does not pass evenly in your life. There are periods when it stretches out as if endlessly, and periods when it slips by so quickly that, when you look back, all that remains is a sense of emptiness. This has nothing to do with clocks or calendars, but is directly tied to how you are experiencing the world around you. When you were young, a single day could feel very long. An afternoon was enough to become bored, to play, to sit still watching clouds drift by, and then to become bored all over again. Moments at that time were not compressed. They opened up, expanded, and left clear, vivid imprints in memory. As you grow older, that feeling gradually changes. Days begin to resemble one another more closely. Morning, noon, and night repeat. Work, movement, and rest follow the same familiar rhythm. When you look back over a long span of time, many things have happened, yet the feeling of them is faint and fragmented. You begin to feel that time is moving faster. This feeling is not an illusion, but it is also not because time itself has accelerated. It arises because the way your brain records and processes experience has changed. In human life, time is first and foremost a psychological experience. You do not directly sense time as an independent entity. What you sense is change. When change is clear and varied, time has depth. When everything repeats and becomes familiar, time is compressed. The brain does not store time. The brain stores events. Novel experiences create many markers. Many details are remembered. When you look back, that stretch of time appears longer because it contains many distinct memories. By contrast, when days pass according to the same pattern, the brain records very little. Few details are retained. Few markers are created. When you look back, that stretch of time seems shorter. Even though in reality it may have lasted for months or years, time does not move faster. Memory becomes sparser. This is why childhood is often remembered as a long, richly textured period, while adult years seem to pass quickly and are harder to grasp. As you grow older, the world becomes familiar. The brain learns to conserve energy by ignoring what is no longer new. It relies on habit. It operates in automatic mode. In this process, experience is compressed and time, as it is felt, becomes thinner. There are moments when the sense of time changes very clearly, especially during waiting or anxiety. 5 minutes can stretch out like an hour. In this state, attention is focused on each passing beat, each small moment, making time feel heavy. Attention slows time and experience. When you constantly monitor time, each minute is clearly marked in consciousness. The sensation of slowness does not come from time itself, but from the fact that you are observing it too closely. By contrast, when you are completely absorbed in an activity, time seems to disappear. You work, create, read, listen, or talk. When you finally look up again, hours have passed without leaving a sense of fatigue or heaviness. In these states, the brain is not tracking time. It focuses entirely on the content of experience. When there is no monitoring, time does not appear clearly in awareness. In dangerous situations, many people describe the feeling that everything slows down. Accidents, collisions, or moments close to risk, details become vivid and sharp, and they are remembered for a very long time. Time in those moments does not actually slow down. What happens is that the brain records more information than usual. When recalled later, the dense volume of memory makes the event seem longer than it really was. The feeling that time slowed down does not reflect a change in time, but a change in how memory was formed. The denser the memory, the longer the experience feels. This reveals an important reality. Even in everyday life, time is not a fixed external flow outside of you. It is constructed from attention, memory, and emotional state. Two people can be in the same place, during the same minute, experiencing the same event, yet carry away two completely different experiences of time. Objective time is the same, but experienced time is not. The brain does not measure time with a clock. It measures it by the degree of change. When change is minimal, time contracts. When change is abundant, time expands. The experience of time follows presence, not the calendar. When you are fully present, experience becomes dense and deep. When you live through habit and automation, experience becomes thin. This is not a judgment of right or wrong, but simply the way the human brain operates. The feeling that time is speeding up does not mean that you are living incorrectly. It simply reflects that many days are unfolding according to the same familiar structure. Few differences are recorded, few markers are preserved. In everyday life, the perception of time is always tied to memory. What is remembered clearly makes time stretch. What is overlooked makes time contract. Time, in your experience, is not an external current pulling you along. It is a structure created by how you pay attention, how you remember, and how you are present in each moment. Time in your consciousness does not reside on a clock. It exists as a direction of movement. You remember what has already happened. You are experiencing what is happening now. You imagine what has not yet arrived. These three domains do not appear simultaneously. They are arranged in a very clear order within the mind. The past is where memory resides. Images, sounds, and emotions that have been stored and can be recalled. They are no longer occurring, yet they are still present within you. When you remember, they become vivid in the unique way that memory brings things to life. The present is the moment you are experiencing. It is thin, brief, and passes very quickly. You are only truly in the present for an instant. The moment you become aware of it, that moment has already turned into memory. The future exists as prediction and expectation. You cannot remember it. You can only imagine it. These imaginings may be clear or vague, depending on your imagination and emotional state. They do not yet have the concrete detail of memory. This arrangement creates a very clear direction in experience. From what has happened, through what is happening, toward what has not yet arrived. This direction is called the psychological arrow of time. You do not experience time in both directions. You do not remember the future. You do not imagine the past as something that has not happened. Your experience always has a single direction. This arrow is not a law of the universe. It is a feature of human consciousness. It arises from the way the brain stores and processes information. Memory is always formed after an event. The brain requires the experience to occur first, and only then does it create a trace of it. For this reason, memory always points backward. You can remember what has happened, but you cannot remember what has not yet occurred. The present is the point of intersection between memory and prediction. It is where information from the senses is processed and then quickly transferred into memory. The present does not last. It is a very thin slice of experience. The future has no memory. Instead, it is constructed from models. The brain uses what has happened before to predict what might happen. These predictions help you prepare, plan, and respond. These three domains do not exist independently. They constantly influence one another. Memory affects how you feel the present. Prediction affects how you allocate attention. Emotions in the present affect how memories are stored. When you are anxious, the future occupies more space in consciousness. When you are nostalgic, the past becomes prominent. When you are highly focused, the present becomes clearer. The experience of time shifts with internal state. The psychological arrow of time also explains why you feel as though you are moving through life. This sensation does not come from time passing over you. It comes from memory being continuously added and predictions being continuously updated. Each new moment creates a new layer of memory. These layers stack upon one another. You experience this accumulation as a flow, but that flow is a flow of information in the brain, not a flow of time outside it. When you wake up in the morning, you carry the memory of yesterday. You have plans for today. As you live through the day, new memories are formed. By the end of the day, you have added another layer of memory. This experience creates the feeling that the day has passed. During sleep, the sense of the arrow of time becomes less distinct. Dreams can mix memory and imagination. The order of before and after is no longer clear. Upon waking, the psychological arrow is re-established. This shows that the arrow of time in consciousness is not self-evident. It depends on the brain's state of activity. When the structure of information processing changes, the experience of time changes as well. Children tend to live closer to the present. Their memories are fewer. Their predictions are less complex. As a result, their experience of time feels open and slow. Adults carry many memories and predictions, making the psychological arrow clearer and stronger. As memories accumulate, the past occupies more space in consciousness. As responsibilities increase, the future becomes heavier. The present is squeezed between these two domains and is easily overlooked. The psychological arrow does not only shape how you experience time, it also shapes how you tell the story of yourself. You think of your life as a sequence of ordered events. You have a beginning, turning points, and goals ahead. This story creates the sense of self. You are the one who has lived through the past and is moving toward the future. Self-awareness is tightly bound to the arrow of time. When memory is damaged or disrupted, this arrow is affected as well. People with memory impairments may lose the sense of continuity of self. The past no longer coheres, and the present becomes fragmented. This shows that the psychological arrow of time is foundational to the human experience. It is not merely how you perceive time, but how you exist in the world. In everyday life, you rarely question this. The psychological arrow operates quietly. It organizes experience, guides action, and creates the sense of continuity that you call life. Time in consciousness does not need to be precise. It needs to be useful. It allows you to learn from what has happened and prepare for what may happen. That is its core function. Therefore, the psychological arrow of time does not reflect the nature of the universe. It reflects how the human brain adapts to the world. It is a survival tool refined through evolution. In your experience, the past is always behind you. The future is always ahead. And the present always passes very quickly. This order is so familiar that it is rarely questioned. But it is precisely this familiarity that makes the psychological arrow invisible. You live inside it without noticing its structure. You experience time as something self-evident. Time, in your consciousness, is not an objective straight line. It is a direction of experience created from memory, attention, and prediction. That direction gives rise to the sense of flow that you call a life. Time as you experience it is not fixed. The same 10-minute interval can pass very slowly at one moment and almost disappear at another. This sensation does not come from the clock, but from how the brain is operating in that particular moment. When you sit and wait, time seems heavier. Each minute is clearly felt. You know that you are waiting. You pay attention to every second that passes. That continuous attention is what makes the experience of time feel extended. By contrast, when you are completely immersed in something, time seems no longer present. You do not think about it. You do not track it. When you finally look up, a long stretch has passed without leaving a sense of fatigue. This difference does not lie in time itself. It lies in the level of attention. The brain has a particular capacity. It can track time, or it can ignore it. When you attend to time, you are continuously marking its flow. Each moment is identified. Each passing beat is registered. The experience becomes detailed and elongated. When you do not attend to time, the brain does not create markers. Experience still unfolds, but it is not divided into segments. When you look back, that period seems shorter. Time in perception, therefore, does not depend on objective duration, but on how experience is segmented. The more segmentation there is, the longer time feels. The less segmentation, the shorter time feels. Emotion also plays an important role. When you are anxious, tense, or bored, the brain becomes vigilant. It constantly scans the environment. It tracks every small change. Time in this state often stretches. When you are excited, curious, or deeply engaged, the brain focuses on the content of experience. It does not allocate resources to tracking time. In this state, time often contracts. This is not a rare phenomenon. It happens every day. Waiting for an important call, sitting through a long meeting, standing at a red light. These moments often feel extended in perception. By contrast, a captivating conversation, a creative task, or an activity you enjoy often passes very quickly. Time is not clearly registered in consciousness. The brain does not have an internal clock that measures time with precision. Instead, it estimates time based on the number of events and the degree of change that occur within experience. When an experience contains many new events and many distinct details, the brain creates many markers. When you look back, that period feels long. When an experience involves little change, there are fewer markers, and time feels short. This explains why monotonous days often seem to pass quickly in retrospect, even though living through them can feel long and tiring. During the experience, attention to time slows it down. In retrospect, the lack of markers makes it contract. The perception of time in the present and the memory of time in the past are not the same. The present is strongly influenced by emotion and attention. Memory is strongly influenced by the number of markers that are retained. A stressful workday may feel long while it is happening, but when you look back months later, that day may feel vague and brief in memory because it resembled many other days. By contrast, a short trip filled with new experiences may pass very quickly while you are living through it. But when you look back, it feels long and vivid because it contains many distinct memories. Time in perception, therefore, has two layers. One layer is the feeling during the experience. The other layer is the feeling during recollection. These two layers can be completely opposite. In dangerous situations, the sensation of time stretching is often very strong. Accidents, collisions, or sudden moments. Everything seems to slow down. Details become clear. Time in those moments does not change. What changes is how the brain records. When facing danger, the nervous system shifts into a heightened state of alertness. More information is recorded than usual. Later, when recalled, the dense volume of information creates the feeling that the event lasted longer. The sensation of time slowing down is a product of memory, not of time itself. The perception of time is therefore tightly linked to biology. It is related to how the brain processes information, allocates attention, and forms memory. It does not directly reflect the structure of the external world. In everyday life, you constantly move between these states. Sometimes attention is high, sometimes relaxed, sometimes emotions are heavy, sometimes light. Each state produces a different experience of time. There is no single experience of time. Time in perception is always flexible. It changes with context, emotion, and degree of presence. This does not mean that time is an illusion. It means that the experience of time is a constructed process. The brain generates a sense of flow to help you orient and act. The stretching or contracting of perceived time is part of this mechanism. It helps you stay alert when vigilance is needed. It helps you forget time when deep focus is required. In human life, time is not only the foundation of motion, it is the foundation of experience. How you perceive time reflects how you are living in that moment. When experience is dense and varied, time has depth. When experience is thin and repetitive, time contracts. This difference does not come from outside, but from how you are present. Time in perception is therefore not a steady stream. It is a flexible structure that shifts with states of consciousness. You do not merely pass through time. You create the experience of time in each moment. Before clocks existed, humans already lived with time, not through numbers, but through signs. Light changed throughout the day. Shadows lengthened and shortened. Temperature rose and fell. These cycles repeated long enough to become familiar, and from that familiarity, humans began to recognize order. At first, time was not measured. It was recognized. Sunrise signaled a beginning. Sunset signaled an ending. Life was tightly bound to the light of the sun. When it was bright, people were active. When it grew dark, people rested. This cycle required no numbers. It was clear enough to provide orientation. The sun became the first clock, not because it was precise, but because it was stable. The shadow of an object planted in the ground moved in a regular way. From this, humans realized that the position of a shadow could divide the day into segments. The sundial emerged in this way. These devices did not measure absolute time. They measured changes in light. They functioned when the sky was clear. They fell silent when clouds intervened. But in a world that did not yet require high precision, this was sufficient. At this stage, time was closely tied to space. Wherever the shadow fell, time was there. Each place had its own rhythm. There was no concept of a shared hour across regions. Each community lived by its own sun. As life became more complex, humans needed ways to measure time that did not depend on light. Night still required a sense of passing time. Long periods of rain still demanded a rhythm of living. From this need, water was brought into the role of measurement. Water clocks emerged as a natural solution. Water flows steadily under the force of gravity. A container, a small opening, and the water level gradually drops over time. This change could be observed and compared. Water did not require light. It flowed day and night. Under stable conditions, the flow of water was fairly regular. This allowed humans to divide time into smaller segments, more precise than the movement of the sun's shadow. But water also had limitations. Temperature affected viscosity. Changes in pressure made flow unstable. Water clocks required constant attention. They revealed that measuring time accurately was more difficult than it appeared. Alongside water, fire was also used to measure time. Candles burn at a relatively steady rate. A candle marked with divisions could indicate how much time had passed. Burning incense, burning oil, all became tools of measurement. Fire offered a different experience of time. It did not flow or pour. It was consumed. Time was perceived as loss. The flame shrank. The candle grew shorter. The passage of time was seen through the disappearance of matter. This method was closer to psychological experience. Time was not only a change of position, but a wearing away. This matched the human sense of life passing, whether through the sun, water, or fire. These methods shared a common foundation. They relied on natural processes. Humans did not create time. They observed regular processes and used them as measures. At this stage, time was still deeply bound to the environment. It depended on climate, terrain, and natural conditions. Each community had its own way of measuring. Differences were not a major issue, because life did not yet require high synchronization. As societies developed, the need for synchronization increased. Trade expanded. Collective activities grew more complex. The unification of time became important. But before reaching that point, humans had to learn how to measure time more steadily. Early instruments did not aim for absolute precision. They aimed for reliable repetition. This reflected how time was understood at the time. Time was rhythm, not number. Day was divided by light. Night was measured by water or fire. Lived time blended with nature. Humans did not stand outside time to observe it. They existed within it. This way of measuring also shaped thought. Time was felt as cyclical. Day followed day. Season followed season. There was no sense of time racing forward. There was only the return of familiar cycles. In such a world, past and future were not sharply separated. What had happened would happen again with the seasons. What was coming had already appeared before. Time was circular, not arrow-like, measuring time by the sun, water, and fire was not merely a technical solution. It reflected the relationship between humans and the world. Time was not something to be conquered. It was something to be observed and adapted to. Precision was not yet the primary goal. What mattered was agreement within the community. When to work, when to rest, when to gather, when to end. Time served the shared rhythm of life. This way of measuring time created a slow experience. There were no seconds, no minutes, only broad intervals. This suited a life connected to nature and biological cycles. Looking back, these early methods of measuring time reveal something clear. Before time became an abstract quantity, it was part of the living environment. It was sensed through sight, through sound, through feeling. Humans measured time not to control it, but to live alongside it. Light, water, and fire were the first companions in that journey. Time, in this period, had not yet separated from the world. It was present in every familiar movement. And from those movements, the idea of time gradually took shape within human experience. Time changed its position in human life with the appearance of mechanical clocks. It was no longer tightly bound to the sky, to flowing water, or to flame. Time was placed inside a device made by humans, one that could be positioned anywhere and function regardless of day or night, weather or season. This shift was quiet but profound. When time was held within gears and pendulums, it became detached from nature. It was no longer seen through light or gradual burning. It was heard through the steady ticking sound, repeating without emotion. Mechanical clocks introduced a new rhythm. This rhythm did not depend on the living environment, but on internal mechanisms. Each second passed exactly like the one before it. This uniformity created a sense of stability. But it also began to shape human behavior. When clocks were mounted on church towers, they did more than tell the time. Bells rang out to divide the day into clear segments: waking, working, praying, resting. Each activity was tied to a specific moment. Time began to command action. From this point on, time was no longer merely a background. It became a standard. Being early or late was no longer a subjective feeling, but a deviation from a shared reference point. Clocks created synchronization, and synchronization created discipline. Time discipline initially served the community. When people followed the same rhythm, collective activities became more efficient. Meetings had start times, rituals had end times, work had shifts, society operated more smoothly. But at the same time, time also became a tool of control. When a system can precisely measure when you arrive, when you leave, and how long you work, it can evaluate and regulate your behavior. Time became a measure of compliance. This shift became especially clear with the arrival of the industrial era. Factories could not operate according to sunlight or personal inspiration. Machines needed to run continuously and in sync. Workers had to adapt to the rhythm of the machines, not the other way around. The clock inside the factory did more than indicate the hour. It divided work shifts, breaks, and meals. Every minute of lateness could be recorded. Time was divided into smaller units, measured precisely, and directly linked to productivity. For the first time, time became clearly tied to money. How long you worked determined how much you were paid. Each hour became a unit of economic value. Time was no longer neutral. It could be bought, sold, and calculated. From this, a new sensation emerged, the feeling of lacking time, not because time had decreased, but because it had been subdivided and assigned tasks. Every empty slot became something to be filled. Every free minute could be seen as waste. Personal clocks appeared and spread, no longer only hanging on walls or towering above cities, but resting on the wrist. Time followed you in every movement. You no longer needed to look at the sky. You only had to glance down. This constant presence altered lived experience. Instead of allowing activities to end naturally, you learned to stop because time was up. Instead of eating when tired or hungry, you ate because it was mealtime. Time began shaping biological rhythms from the outside. Gradually, time discipline was internalized. No one needed to remind you. You checked the time yourself. No one needed to supervise you. You felt anxious when you were late. The clock was no longer an external tool. It became part of consciousness. The most effective form of control is control that requires no enforcement. When you believe you must be punctual, must make use of every minute, the system no longer needs to intervene. You regulate yourself according to the shared rhythm. In modern society, clocks are everywhere, on phones, on computers, on public displays. Time is continuously shown, precise down to the second. This precision creates invisible pressure. You do not only know where you are in space, but where you are in a schedule. Every moment can be compared against a plan. When you fall behind that plan, unease arises. Time, in this role, is no longer a natural flow. It is a network of markers. Living becomes a movement from one marker to the next. The spaces between markers grow increasingly narrow. This affects not only work, but how you view life itself. Activities that do not produce measurable value are easily devalued. Rest, reflection, and silence become difficult to justify in a system that optimizes time. It is important, however, to see clearly that clocks do not create control by themselves. They are tools. How society uses them determines their role. Clocks enable coordination, but they also enable surveillance. When time is standardized, power can extend further. A single center can set a shared time for many regions. Local differences are blurred. Rhythms of life become uniform. This uniformity brings efficiency, but it also erodes diversity of experience. Personal time must yield to collective time. Individual rhythms are pressed into a common mold. In this context, the experience of time becomes more tense, not because time moves faster, but because expectations increase. More tasks must be completed within the same span. Clocks do not make time pass faster. They make you aware of every small portion of time. This constant awareness creates a sense of urgency, even when no direct pressure is present. From a measuring instrument, the clock became a tool for organizing society. It shapes how people work, how they rest, and how they are evaluated. Punctuality becomes a virtue. Lateness becomes a fault. Looking back, a crucial transition becomes visible. Time is no longer only something to be experienced. It is something to be managed. And when something is managed, it can be used to control. You live in a world where time is present in every decision, and precisely for that reason, understanding the role of the clock helps clarify the relationship between time and freedom. Time does not simply flow. It is arranged, demanded, and expected. The clock marks the beginning of a new phase, a phase in which time steps out of nature and into social structure. From this point on, the experience of time no longer belongs solely to the individual, but is tightly bound to the system in which you live. The need to measure time precisely did not arise from philosophical curiosity, but from very real practical limits. When humans began to travel farther across the seas, time was no longer merely a way to organize daily life. It became a condition for survival. On the open ocean, determining north-south position is relatively easy, using the sun or the stars. But east-west position, or longitude, presents a different problem. There are no obvious natural signs to indicate where you are along that axis. To determine longitude, you need to know the time difference between your current location and a fixed reference point. The Earth rotates 360 degrees in 24 hours. Each hour corresponds to 15 degrees of longitude. If you know the exact time at the reference point, you can infer your position. The difficulty lies in keeping that reference time throughout the journey. On a ship at sea, temperature changes, humidity is high, and constant motion causes vibration. Ordinary clocks drift quickly. A small error in time can translate into a positional error of tens of kilometers at sea. For centuries, this was a problem with almost no solution. Thousands of ships were lost, ran aground, or sank simply because their crews did not know precisely where they were. Time, at this point, became a factor that determined safety and survival. The revolution began when approximation was no longer accepted. Clocks had to operate reliably regardless of environment. They had to keep steady time for months, even years, without adjustment. The first marine chronometers marked a turning point. They did not rely on light or flow, but on refined mechanisms optimized for stability. Error was reduced to levels never before achieved. For the first time, time could be carried. It was no longer fixed to a single place. You could bring standard time from land out onto the ocean. Vast spaces were linked by a shared rhythm. From this point, world maps changed. Sea routes became safer. Global trade expanded. Precise timekeeping did not merely solve a technical problem, it opened a new era of connection. But the revolution in time measurement did not stop with mechanics. As science advanced, it became clear that all physical mechanisms are affected by their environment. Metals expand with temperature. Friction is never zero. Error always remains. To move beyond these limits, humans turned to systems more stable than any machine. Instead of relying on large objects, they relied on the behavior of the smallest entities. At the atomic level, laws become more consistent. A given atom, under defined conditions, always oscillates at the same frequency. It does not care about room temperature or the motion of a ship at sea. This idea led to the creation of the atomic clock. Instead of counting the oscillations of a pendulum or gears, atomic clocks count the oscillations of atoms. Each oscillation is a tick of time. The chosen atom is not arbitrary. It has a stable structure, a clear signal, and is easy to measure. Its oscillations repeat with near-perfect precision. Time, for the first time, was anchored to the nature of matter itself. A second was no longer a vague fraction of a day. It was defined by an exact number of atomic oscillations. This definition does not depend on the Earth, the Sun, or human convention. Time became a universal quantity in a deeper sense. Anywhere in the universe, the same atom oscillates in the same way. Time measured by atoms carries no local signature. The level of precision achieved is difficult to imagine. The error of modern atomic clocks is so small that if one had been running since the birth of the universe, it would still not be off by a single second. Time is measured almost absolutely. This precision does not serve science alone. It permeates daily life in ways you rarely notice. Global positioning systems operate by comparing time signals from multiple satellites. Each satellite carries its own atomic clock. Signals are transmitted with extremely precise timestamps. Your device receives these signals and calculates position based on differences in arrival time, with even a tiny timing error. The displayed position could be wrong by kilometers. The fact that you know where you are is a direct consequence of measuring time with near absolute precision. This reveals an interesting reversal. Originally, humans measured time to understand space. Now, they use time to locate themselves in space. Time becomes the foundation for perceiving the world. The more precisely time is measured, the more complex it appears. When atomic clocks reached extreme sensitivity, effects once ignored began to emerge. Time does not flow the same everywhere. Clocks placed at different altitudes run at different rates. Clocks moving at high speed run slower than those at rest. These differences are tiny, but large enough for atomic clocks to detect. Precise time measurement is not just a technical achievement, it is a doorway. As precision increases, deeper properties of time gradually reveal themselves. Time is no longer an immutable backdrop against which everything else is measured. Instead, it becomes something that must itself be understood. Absolute precision exposes relativity. The revolution in time measurement carried humanity from the sky to gears, from gears to atoms. Each step aimed to eliminate error, yet each step also revealed greater complexity. Time was once tied to day and night, then to mechanisms, then to atoms. With each separation, it became more abstract, more precise, and less intuitive. When time is measured by atomic oscillations, it seems disconnected from lived experience. Yet it is precisely then that a new question emerges. If time can be measured with such precision, what is it that is truly being measured? A flow, a vibration, or a deeper property of the universe? This revolution does not close the story of time. It makes the story more serious. As humans measure time better than ever before, they also begin to suspect that time is not as simple as once believed. And from here, time is no longer just something that is measured. It becomes something that must be. For many centuries, time was regarded as a solid foundation. It existed on its own, flowing evenly, independent of anything that happened in the universe. All events simply unfolded within it, like movements on an unchanging plane. In this view, time required no explanation. It was there before all things. It continued to flow whether or not there was motion. You could imagine a completely empty universe, and time would still pass steadily through that void. This conception placed time in an absolute position. 1 second here was identical to 1 second anywhere else. A moment occurring on Earth happened simultaneously with that same moment in a very distant galaxy. Regardless of the immense distance between them, space and time were entirely separate. Space was where objects existed. Time was what marked when events occurred. They did not influence one another. Motion through space did not alter the flow of time. This view aligned deeply with everyday intuition. When you drop an object, it falls at the same rate no matter where you stand. When you measure a duration, you expect others to obtain the same result. From this foundation, the universe was imagined as a vast machine. Each component moved according to clear laws. Every motion had a definite cause. There was no room for ambiguity or randomness. If you knew the exact state of every object at a given moment, you could calculate their states at any other moment. Past and future were both accessible to calculation. In this picture, time was merely an axis for arranging events. It did not intervene. It did not deform. It did not respond to what happened within it. It was simply a steady, unchanging flow. This led to a powerful sense of reassurance. The universe was orderly. Everything followed laws. Nothing was truly unexpected if you had sufficient information. Time was the foundation upon which this determinism operated. In such a world, the future was already determined by the present. What you do today is the consequence of what came before, and what will happen tomorrow is already written in today's state. The feeling of freedom, in this context, becomes ambiguous. If every motion of matter follows strict laws, then human actions also lie within that causal chain. Choice appears to be just another link. Yet this view went unquestioned for a long time. It worked too well. It accurately predicted the motion of planets, the trajectories of comets, and the behavior of objects in everyday life. Bridges were built upon it. Machines were designed according to it. Trains ran on schedule because of it. Absolute time became the invisible pillar of a technical society. In this model, simultaneity was also absolute. If two events occurred at the same time for you, then they occurred at the same time for everyone else. Differences lay only in who observed them sooner or later. Light took time to travel, but this did not alter the events themselves. The events occurred in absolute time, and information about them simply reached you later. This understanding created a clear order. There was a shared present for the entire universe. There was a shared past that had already passed. There was a shared future waiting ahead. Time, in this picture, resembled a straight river. It flowed steadily from source to mouth. Everything was carried along at the same speed. No one could move slower or faster than its current. Crucially, this model did not treat time as part of the material universe. It was not affected by mass, motion, or energy. It existed independently, like an abstract framework. Because of this, time became invisible. You could not act upon it. You could only measure it. You could only follow it. It was foundational, yet non-participatory. In everyday life, this view remains very strong. You plan based on the assumption that time flows the same for everyone. You expect your clock to match other people's clocks. You believe that 1 hour today is identical to 1 hour yesterday. You believe that time does not change with circumstances. This belief is deeply embedded in how you organize your life. Because it is so familiar, it is rarely questioned. Absolute time is like air. It is present but unnoticed. Only when something does not align do questions arise. Within this framework, the universe operates like a vast calculation. Each moment is the inevitable result of the moment before it. There is no room for flexibility within time itself, but this certainty also carries a limitation. When time is regarded as absolute and immutable, any discrepancy must be explained by some other cause. Time is never the suspect. This view laid the foundation for classical science, but it also locked time into a passive role. It was not allowed to bend. It was not allowed to differ. In such a universe, measuring time more precisely only helps trace trajectories more clearly. It does not change the nature of time. Time continues to flow evenly, no matter how refined the measurement becomes. Only when measurements reached extreme precision did small discrepancies begin to appear. Not in the motion of objects, but in the very assumption about time itself. These discrepancies were initially tiny, easy to overlook, but they did not disappear. They accumulated, raising questions about a foundation once thought unshakable. Absolute time had long been a firm anchor. It allowed humans to believe that the universe could be fully understood through laws and calculation. But that very firmness made every small tremor stand out. In the classical picture, time did not change. Yet as the world was observed more closely, this very assumption began to require reconsideration. The universe as a deterministic machine is a powerful image. It brings order, predictability, and a sense of control. But every machine rests on assumptions about how its parts function. When one of those assumptions is questioned, the entire machine must be re-examined, and time, once a silent foundation, gradually became the center of doubt. If the universe operates like a deterministic machine, the consequences do not remain within physics alone. They reach directly into how you understand yourself. When every motion follows law, an unavoidable question arises. Do you truly choose, or are you merely carrying out a chain of outcomes arranged in advance? This idea is pushed to its logical extreme in a famous thought experiment. A hypothetical intelligence, not limited by senses or instruments, knows the exact position and velocity of every particle in the universe at a single moment. Nothing is omitted. There is no error. With that information, this intelligence could calculate the entire past and the entire future of the universe, not through vague prophecy, but through precise computation. Everything that has happened and everything that will happen is derived necessarily from the present state. In this picture, the future is not something that has not yet arrived. It already exists as a deterministic result. What you will do tomorrow is encoded in the material state of today. The thoughts you're about to have are decided by the motion of atoms in your brain. Human beings, in this view, are not free agents, but parts of a mechanism. The brain is a complex physical system, yet it still follows laws. Decisions are merely the outcome of initial conditions and subsequent interactions. The feeling of choice still exists, but it is treated as a subjective experience, not evidence of real freedom. You feel as though you are deciding, but that decision was already determined by a causal chain extending far back. This idea is unsettling not because it is complicated, but because it is direct. If it is true, then responsibility, morality, and personal effort all become fragile concepts. If you could not have done otherwise, what meaning remains in judging actions? In a deterministic universe, there is no moment that is truly open. Each moment is only the necessary continuation of the moment before it. The present is not where choices are created, but where outcomes are manifested. What is striking is that this idea does not arise from pessimism or skepticism. It arises from a strong faith in the explanatory power of science. If laws are complete and information is full, there is no place left for indeterminacy. For a long time, this view was regarded as the natural consequence of classical science. It was not seen as extreme, but as consistent. The world could be calculated, and human beings were part of that world. However, when applied to lived experience, a tension emerges. You do not live as though everything has been decided. You hesitate. You weigh options. You regret. These states imply that different possibilities once existed. The feeling of regret is especially important. When you think you could have acted differently, you are assuming the world had more than a single path. But in the deterministic model, that feeling is only a retrospective illusion. In this view, even your sense that you could have done otherwise was itself determined. Subjective experience does not change the objective nature of the causal chain. The feeling of freedom is not the same as freedom. Some attempt reconciliation by redefining freedom. Freedom is no longer the ability to do otherwise under the same conditions, but the ability to act from inner motives without external coercion. In this sense, if your actions arise from your desires, beliefs, and character, they are considered free, even if those factors have deeper causes. Freedom becomes a concept compatible with determinism, but this reconciliation does not erase the core question. If your desires and beliefs are also determined in advance, how much freedom remains? Changing the definition does not remove the original intuition. This question cannot be settled by argument alone. It touches the way you feel yourself to be. You are not merely an object moving through space. You are a subject of experience. The difference between external description and internal experience creates a gap. Science describes processes. Experience gives you a sense of agency. These are not easily reconciled. In the deterministic model, time functions as a fixed axis. The past determines the present. The present determines the future. There is no room for true randomness. Every surprise is only ignorance. If an intelligence powerful enough existed, it would not need to wait for the future. The future would already be present in calculation. This changes the way time is understood. Time is no longer a space of possibilities, but a sequence displaying what has already been determined. In this picture, the present is not a crossroads. It is a point on a track. You do not choose the direction. You are being carried along. It is precisely this thoroughness that makes the model controversial. It leaves no gray zone. Either the universe is completely deterministic, or there is something that cannot be calculated. For a long time, many accepted this cost because the success of classical science was so great. The world operated exactly according to laws. There was no reason to suspect that humans were an exception. But this confidence rests on a crucial assumption, that physical laws are sufficient to describe every aspect of reality, that there is no deeper layer where indeterminacy might arise. As long as that assumption remains intact, Laplace's demon is a logical consequence. It does not need to exist in reality. It only needs to be possible in principle to pose the problem. If in principle the future can be calculated, then in essence it is already fixed. Human practical inability does not change that. Yet it is precisely at this point that cracks begin to appear, not from philosophy, but from physics, not from subjective experience, but from the effort to measure the world at deeper levels. The deterministic machine begins to encounter limits that cannot be ignored, and with it, the image of the all-knowing demon begins to wobble. But before those limits become clearly visible, this model has already left a lasting mark. It forces you to face the hardest question. If everything has a cause, where do you stand in that chain? That question does not disappear even when the model changes. It only changes form. And for that reason, Laplace's demon is not merely a physical thought experiment. It is a test of how you understand freedom, responsibility, and yourself within an orderly universe. In the classical picture, the answer leans toward determinism. But the story of time does not end here. In the classical picture, time flows evenly and independently. Yet it was light, the most familiar thing of all, that first exposed the crack, not through philosophical speculation, but through precise measurement. Light has a strange property. Whether the source is moving or stationary, whether the observer approaches or moves away, the speed of light appears not to change. This does not align with ordinary mechanical intuition. For everyday motions, velocities always add. If you run on a moving train, your speed relative to the ground is the sum of the two motions. But light does not obey that rule. As measurements became increasingly precise, the result remained the same. Light always travels at the same speed in a vacuum. No deviation, no exception. This raised a serious question. If the speed of light is fixed, then something must change to make this true for all observers. It cannot be space, because distances can be measured. It cannot be light, because it is already fixed. Only one possibility remains. Time cannot be absolute. In the old model, time was a shared foundation. Everyone shared the same rhythm. But if two observers in different states of motion both measure the same speed of light, then their time rhythms cannot be the same. This is not a psychological effect. It has nothing to do with seeing light sooner or later. It concerns how time itself is measured at the location where events occur. When two observers view the same event from different states of motion, they do not merely disagree about position, they disagree about time. Simultaneity is no longer absolute. In the new picture, two events may occur at the same time for one observer, but not at the same time for another, not because of measurement error, but because the structure of time does not allow a shared present. This undermines, at its root, the way humans understand temporal order. Past, present, and future are no longer layers stacked identically for everyone. Time begins to depend on motion. Each observer carries a personal rhythm. There is no universal cosmic clock hanging outside all frames of reference. This shift does not arise from a rare phenomenon. It emerges from light itself, something present everywhere. Every time you see, measure, or receive information, you are interacting with light. That means this crack cannot be hidden. It lies within every measurement. Previously, precision simply was not high enough for it to stand out. As precision increased, old assumptions began to clash with data. Space and time could no longer be treated as two separate, immutable entities. If time stretches and contracts with motion, then it is no longer a passive backdrop. It becomes part of physical structure. It responds, adjusts, and changes. In this world, there is no single time rhythm for the entire universe. Each moving system carries its own timeline. These timelines are not perfectly parallel. This collapses the idea of a universal present. There is no single moment shared by the whole universe. Each observer has their own present. Light, by preserving its constant speed, forces time to relinquish absoluteness. It does not attack directly, but it does not yield. There is no way to keep both assumptions intact. Either time is absolute and light obeys velocity addition, or light is invariant and time must be flexible. Experiment chose the second option. This collapse did not happen loudly. There was no moment when the universe shook. It unfolded in laboratories, in delicate measurements, in numbers that refused to match old theory. At first, many patches were proposed. Some suggested that objects contract along the direction of motion. Others proposed that clocks mechanically slow down. But these fixes were temporary. They did not explain the essence of the problem. They preserved the old framework by adding auxiliary assumptions. But the data increasingly demanded a deeper change. When the old framework was pushed to its limits, the inevitable occurred. absolute time could no longer stand. From this point on, time could not be treated as a flow external to events. It became inseparable from motion and observation. It turned into part of the relationship between frames. This change removed the comfort of the old model. If time differs for each observer, then the notion of a shared order becomes more complex. Yet at the same time, it opened a deeper understanding. Time is not a pre-given ruler. It is a property of how the universe operates. Light, in this role, is not merely a carrier of information. It is the standard. Every frame of reference must adjust itself to it. That standard does not care about human intuition. It does not bend to fit expectation. It exists as a physical constraint that all descriptions must respect. Once you accept the invariance of the speed of light, you are forced to accept that time is not the same for everyone. There is no middle path. The collapse of absolute time is not a total loss. It is a replacement. An old structure is dismantled to make room for a more subtle one. In the new structure, time does not disappear. It changes its role. It is no longer a silent foundation, but an active component of reality. Events do not merely have positions in space. They have positions within a larger structure, where distances and time intervals are intertwined. What matters is that this change is not based on speculation. It is grounded in light, something that cannot be ignored. Every precise measurement confirms the same conclusion. Absolute time was once a pillar, but light, through its unwavering fidelity to its speed, cracked that pillar. From that crack, a new way of seeing time began to form, no longer a single shared flow, but multiple rhythms, linked by a deeper structure of the universe. And once time is no longer absolute, everything that was built upon it must be reconsidered. Time no longer retained the role of an immutable foundation with the emergence of special relativity. In this new view, time does not flow in the same way for everyone. It depends on motion. This is not a metaphor or a subjective sensation, but a direct consequence of physical laws. Special relativity begins with two simple postulates. The laws of physics take the same form in all inertial frames of motion, and the speed of light in a vacuum is the same for all observers, regardless of how they are moving. These two statements are sufficient to transform the entire structure of time. When light maintains a constant speed, other quantities are forced to adjust. Distances can contract. Time rates can slow down. There is no way to keep everything as it was. Time, for the first time, enters the list of things that can change. The most direct consequence is time dilation. A moving clock runs more slowly than a clock at rest. This does not depend on the clock's mechanism, whether it is a mechanical clock, an electronic clock, or a biological heartbeat. All are affected in the same way. This slowing is not an observational illusion. It does not arise from delayed signal transmission. It occurs at the very place where the clock operates. Time in the moving frame genuinely flows more slowly than in the stationary frame. At the familiar speeds of everyday life, this effect is extremely small. It does not affect daily activity. But as speed increases toward the speed of light, the difference becomes pronounced and impossible to ignore. A journey at very high speed causes time on the vehicle to pass more slowly than time at the point of departure. Upon return, the traveler will be younger than those who stayed behind. This is not a paradox, but a measurable outcome. Time, in this context, is no longer a shared yardstick. Each observer carries their own clock, and those clocks do not have to agree. There is no global time imposed on all. Alongside time dilation comes length contraction. A moving object becomes shorter along the direction of motion when measured from a stationary frame. Space and time are no longer independent. They adjust to one another to keep the speed of light constant. This leads to a deeper change. Simultaneity is no longer absolute. Two events may occur at the same time for you, but not at the same time for someone else moving relative to you. There is no single present shared by everyone. The concept of the present, in special relativity, becomes local. It is tied to a frame of motion. This does not cause the order of the world to collapse, but it forces that order to be understood in a more subtle way. Time is no longer a flow external to events. It is part of the structure within which events occur. Space and time combine into a single entity, where position and moment cannot be separated. Within this structure, each event is specified by 4 coordinates, 3 for space and 1 for time. No event can be fully described without all four components. Motion through space directly affects motion through time. When you move faster through space, you move more slowly through time. This is not an arbitrary trade-off, but a necessary relationship. Special relativity does not merely change calculations, it changes understanding. Time is no longer a silent background. It becomes a flexible component of reality, responding to motion. This has very practical consequences. Modern navigation systems must account for time differences between moving clocks and stationary clocks. If ignored, errors would rapidly accumulate. Clocks orbiting above Earth tick at a different rate than clocks on the surface. The effect is small, but sufficient to disrupt entire systems if not corrected. Relative time becomes a technical factor. In this context, saying that time runs fast or slow must be specified. There is no absolute time against which to compare. Every statement must be tied to a particular frame of reference. You cannot ask whether time runs fast or slow in general. You can only ask whose time, in what state of motion, is being compared with whose. This deeply alters intuition. In everyday life, you are accustomed to thinking that everyone shares the same time rhythm. Special relativity says this is only approximately true within narrow limits. Time becomes personal in a physical sense, not a psychological one. Each trajectory through the universe carries its own time rhythm. These rhythms do not contradict one another, but they do not coincide. Even so, special relativity does not destroy causal order. Although time is relative, causes still precede effects. Light sets a limit on all influences. No information travels faster than light. This limit prevents the world from falling into chaos. Time may stretch or contract, but causal structure is preserved. What can affect what is clearly defined? Time, in special relativity, is both flexible and strict. Flexible in its rate of flow, strict in its relational structure. It is no longer a clock hanging outside the universe, but neither is it an illusion. This new perspective does not deny everyday experience. At low speeds, all relativistic effects are extremely small. Time appears absolute because differences are too small to perceive, but this does not make the deeper structure disappear. It is merely concealed by habit. When conditions change, that structure becomes unmistakable. Special relativity places time at the center of modern physics. It is no longer a secondary parameter. It is an essential component for accurately describing the world. When time becomes relative, many old questions must be asked again, not to deny them, but to understand them correctly. Time does not vanish. It changes its nature. In this view, you do not merely live in space. You live within a structure where time and space are intertwined. Every motion is a motion within that structure. Special relativity does not make the world vague. It makes the world more precise, even if less intuitive. Time is no longer simple, but it becomes profound. When time is no longer absolute, you do not lose order. You enter a different order, where the rate of flow depends on the journey, and every journey carries its own time. Time dilation is not a secondary detail in special relativity. It is a direct and unavoidable consequence. When motion changes, the rate of time changes with it, not in perception, but in the physical process itself. This may sound abstract until it is placed in a concrete situation. Two people are identical, the same age, born at the same moment, carrying identical clocks. Then they separate. One remains in a familiar state of steady motion. The other embarks on a journey at a very high speed, high enough for relativistic effects to become significant. When they meet again, what occurs does not align with initial intuition. The one who traveled fast returns younger. That person's clock has run more slowly, not because of malfunction, not because of environmental conditions, but because time along that journey truly flowed more slowly. At first glance, this creates a sense of paradox. If motion is relative, why can we not say that the one who stayed behind was the one moving? Why can the conclusion not be reversed? This confusion comes from applying old intuition to a new structure. In special relativity, not all motion is perfectly symmetric. Uniform straight-line motion and motion involving changes of state are not the same. The traveler does not merely move uniformly. That person accelerates, changes direction, and returns. The trajectories through space and time are not the same. It is precisely this difference that makes the accumulated time unequal. Time, in this context, is not just a rate at a point. It is the total time accumulated along a path. Each path through spacetime carries its own amount of time. The two people begin and end at the same two events, but the paths connecting those events are different. And in relativity, different paths lead to different times. There is no logical contradiction here. There is only the breakdown of familiar intuition. An intuition built in a world where speeds are low and time is nearly absolute. As speed approaches the limit, the true structure of time is revealed. Time is not a shared flow for all journeys. It depends on how you move through space. Crucially, this effect is not confined to theoretical examples. It has been tested many times. Clocks carried on airplanes run more slowly than clocks on the ground. Clocks on satellites tick at different rates from clocks at lower altitudes. These differences are extremely small in everyday life, but they are consistent. They cannot be ignored as precision increases. They force all technical systems to take them into account. Time dilation is not a random stretching. It follows an exact formula. The greater the speed, the more slowly time flows. There are no exceptions. This leads to a new way of viewing age and lifespan. Age no longer depends solely on the number of Earth's rotations. It depends on your journey through the universe. Two people may be born together and die together, yet experience different amounts of lived time if they follow different paths. Age becomes a quantity tied to trajectory, not just to calendars. This does not make the concept of age meaningless. It makes it more precise. Age is the amount of time a physical system accumulates along its path. In this context, time is no longer a shared flowing background. It is something generated along motion. Each journey carries its own clock. The sense of paradox appears only when you try to retain the idea of a common time. When that idea is abandoned, everything becomes consistent. There is no absolute priority given to any frame of motion. There is no cosmic clock for comparison. There are only clocks that meet at shared events and compare results. When the two people meet again, they do not argue about who is right. They compare clocks. The clocks give the answer, and the answer depends on the journey, not on opinion. This changes how past and future are understood. There is no single timeline that everyone shares. Each person carries their own temporal history. Even so, this does not lead to chaos. Causal structure is preserved. Causes do not come after effects. The speed of light protects this order. Time dilation does not allow travel into the past. It does not allow information to be sent backward along causality. It only allows time to flow at different rates. This difference is not a feeling. It does not depend on awareness. It exists even when there is no observer. A fast-moving particle decays more slowly. A fast-moving clock runs more slowly. All physical processes are affected in the same way. This shows that time is not an external layer draped over processes. It is part of the structure that determines the rate of those processes themselves. When time dilates, everything within that frame dilates together. There is no way for a single process to escape the shared influence. The twin paradox is therefore not a true paradox. It is a point of collision between old intuition and new structure. When intuition is adjusted, the contradiction disappears. Time does not flow the same for everyone, but that does not make the world disordered. It only makes the order more subtle. You cannot ask whether time flows faster or slower in an absolute sense. You can only ask how time flows along a particular path. Each path is its own time story. When paths meet, the stories are compared, and any difference that appears is not an error. It is the nature of things. Time dilation reveals something profound. Time is not the stage on which events take place. It is part of the script. You do not merely live in time. You create time by how you move through the universe. And when two people meet again after different journeys, the difference in age is not strange. It is the physical trace of the different paths they have taken. Time, from this point on, is no longer a single shared flow. It is a network of individual flows, intertwining, meeting, and separating according to the structure of space and motion. Time does not depend only on motion. It also depends on gravity. When mass is present, the rate at which time flows changes, not as a secondary effect, but as part of the fundamental structure. In this understanding, gravity is no longer a mysterious pulling force between objects. It is the deformation of space and time. Mass curves the structure that all motion must follow, and when that structure is curved, time cannot maintain a uniform rhythm. Near a massive object, time flows more slowly. A clock placed lower runs more slowly than a clock placed higher. This difference does not come from the clock's mechanism. It comes from the gravitational environment itself. This may sound counterintuitive. You are used to thinking that gravity affects only falling motion. But here, gravity affects the rate of time of all processes. Everything unfolds more slowly in a region of stronger gravity. There are no exceptions. Heartbeats, chemical reactions, atomic oscillations, all slow down by the same factor. Time does not discriminate. It bends everything. This view unifies two things that were once separate. Motion changes time. Gravity also changes time. Both are expressions of the same deeper structure. Within that structure, space and time are no longer flat backgrounds. They form an entity that can curve, twist, and deform. Matter and energy determine the shape of this entity. When a massive object is present, it does not pull other objects in the usual sense. It makes the straightest paths in space and time become curved. Objects simply follow those paths. Time is bent in a similar way. Near large masses, the path through time shortens. The flow of time slows. Far from mass, time flows faster. This difference is extremely small under familiar conditions, but it is not zero. When measured with sufficient precision, it is always present. Clocks placed on a mountain run faster than clocks placed at the base, not because of thinner air, not because of temperature, but because gravity is weaker at higher altitude. This difference has been measured directly, not by inference, but by atomic clocks placed at different heights. The results match the predictions exactly. This shows that time is not something you carry independently. It depends on where you are within the gravitational structure of the universe. Time, in this sense, becomes local. Each location has its own rate of flow. There is no single time imposed across all of space. This structure also explains why light bends when it passes near massive objects. Light has no mass, but it follows the curved structure of space and time. When the structure is curved, the shortest path is no longer a straight line in intuitive terms. Light simply follows the shortest path in that curved structure. Space and time are no longer a stage. They are actors. They participate in the dynamics of the world. This changes how gravity is understood. It is no longer an instantaneous force acting at a distance, no longer an invisible pull. Gravity becomes geometry. This geometry is not static. It changes with the distribution of matter and energy. When matter moves, the structure changes with it. Time adjusts its flow accordingly. In regions of very strong gravity, the effects become extreme, near objects of enormous mass. Time flows so slowly that the difference becomes significant. For a distant observer, processes near such regions appear stretched out, in the extreme limit. Time can nearly come to a halt for a distant observer. This is not a metaphor. It is a mathematical consequence of curved structure. Yet for someone within the gravitational region itself, time still flows normally. Their clock shows nothing unusual. All processes proceed as usual. The difference appears only when comparisons are made between different locations. There is no shared rhythm to serve as a standard. Each location carries its own time. This does not create contradiction. It creates a network of time, a network that links different rates through geometric relationships. Within this network, asking whether time flows faster or slower has no meaning unless location and gravitational conditions are specified. Time has no absolute speed. This view deepens the understanding of age. Age depends not only on motion, it also depends on the gravitational environments you experience. Two people living under different gravitational conditions will accumulate different amounts of time. The difference is small, but real. Lived time becomes a trace of both motion and position within the gravitational structure. It is not merely a count of days on a calendar. In everyday life, you do not notice this difference, but modern technical systems must account for it. Otherwise, errors accumulate rapidly. Navigation systems must adjust clock rates because gravity differs between orbit and the ground. If ignored, positioning drifts. This shows that general relativity is not a distant theory. It is present in everyday technology. Even if you are unaware of it, time bending is not something strange that happens far away. It happens here, right now, at a very small scale. This small difference accumulates over time. And it is precisely this accumulation that confirms time is not a rigid background. Time responds to mass. It bends under gravity. It is a flexible part of the structure of the universe. In this understanding, space, time, matter, and energy are not separate. They form a unified system. You do not stand outside time to observe it. You are inside the structure that is being curved. Your rate of time depends on your position within that network. General relativity does not make time vague. It makes time more concrete. Concrete in its relationship to mass and energy. Time does not merely flow, it bends according to the shape of the universe, and that shape is determined by what the universe contains. When gravity bends time, time does not disappear. It reveals a deeper geometric nature, a nature that everyday intuition cannot grasp, but precise measurement can. In this structure, time is no longer an independent flow. It is part of the shape of the universe, and every moment you experience is a slice through that shape. Black holes are not only extreme objects in the universe, they are places where every familiar assumption about time is pushed to the limit. If any remnant of the idea of a shared present for everyone still remains, then a black hole is where it collapses completely. In the familiar world, you implicitly believe there is a moment called now, wherever you are, whatever you are doing. You still assume everyone else is living in the same present, only in different locations. Relativity has shaken that belief. Black holes make it impossible for it to stand. Near a black hole, gravity becomes so strong that time is stretched to an extreme degree. The closer a clock is placed to the black hole, the more slowly it ticks compared with a clock far away. This is not a guess. It is a direct consequence of violently curved space-time structure. For a distant observer, every process near a black hole seems to slow down. An object falling toward the black hole looks as if it is frozen, moving ever more slowly, its light becoming redder and weaker. Time there appears to almost stop, but for the one who is falling, there is no moment of stopping. Their time flows normally. Their clock registers nothing unusual. The heart still beats. Thought continues. Their present still exists. These two descriptions do not contradict each other. They are both true, but they belong to two different frames of observation. And it is precisely here that the concept of an absolute present disintegrates. There is no shared moment that both observers can call now. What the distant observer describes as an infinitely drawn-out process is a finite span of time for the falling observer. The two timelines cannot be fused into a single present. The boundary of a black hole, where light can no longer return, makes this break even clearer. For the distant observer, there is no definite moment when the object crosses that boundary. The process stretches on forever. It never completes within their time. But for the falling observer, that boundary is crossed within a finite moment. There is no special sign at that instant, no alarm bell, no barrier wall. Their present continues beyond a boundary the distant observer will never witness. Two stories about the same event exist in parallel, unable to be reduced to a single shared sequence. There is no way to place them on one time axis that everyone agrees on. This completely breaks the idea that there is a universal present covering the entire universe. The present becomes a local concept, tied to each observer. Each path through spacetime. Black holes do not create this problem. They simply expose it more clearly than any other phenomenon. In weak gravitational fields, the differences are too small to notice. Near a black hole, the differences become impossible to avoid. In this context, the question what is happening now becomes meaningless unless you specify who's now. Time is no longer a common background into which all events can be placed. This has profound implications for how you think about reality. If there is no shared present, then the universe is not a single moment unfolding simultaneously everywhere. It is a structure in which moments exist differently for different observers. Black holes show that time does not only stretch and contract, it can separate experiences so thoroughly that they cannot be reconciled into a single narrative, not because information is missing, but because the structure does not allow it. This also changes how causality is understood at an extreme boundary. For the distant observer, every influence from inside the black hole's boundary disappears from their present. No information crosses outward. Their time never contains those events. But for the one inside, Events still continue, still have order, still have before and after. Causality is not broken in their experience. It is only cut off from someone else's timeline. There is no logical contradiction. There is only a radical separation of timelines. What was once assumed to be a single shared flow now branches in a way that cannot be rejoined. A black hole, therefore, is not only a place where light is trapped, it is a place where the present is fragmented. There is no single moment shared by both inside and outside. This shakes a very deep intuition, the intuition that the world is unfolding together. In reality, each part of the universe has its own present, and those presents do not necessarily coincide. In the familiar world, the alignment is close enough that you do not notice. In an extreme environment, the difference is revealed plainly. Black holes show that speaking of the present of the universe is an imprecise way of speaking. There is only the present of each trajectory, each observer, each position in the structure of spacetime. This does not make the universe chaotic. It forces your description to become more subtle. Reality is not simply a moment passing by. It is a network of moments, linked but not synchronized. Within that network, black holes are knots where timelines separate most strongly. They do not converge again. They do not share a common now. When you look at a black hole, you are not only looking at a dark object, you are looking at the limit of the concept of the present, where the question what is happening right now no longer has a single answer. Time, in this context, is no longer a shared flow for the entire universe. It is a collection of separate flows, each tied to a way of moving through spacetime. The death of the absolute present is not a philosophical catastrophe. It is the inevitable consequence of understanding the universe more precisely. As the structure becomes clear, concepts that are too simple are forced to fall away. Black holes simply do it without compromise. They do not allow you to keep the old idea through negotiation. Either you accept that the present is local, or you cannot describe what happens. In this view, time does not disappear. It becomes richer. But that richness requires you to relinquish the comfort of a shared present. The universe does not live together in a single moment. It exists as a structure in which each journey carries its own time, and black holes are where that truth becomes most unmistakable. At the familiar level, the past is regarded as complete. What has happened has happened. It cannot be changed. Time flows from the past to the present and then to the future in a clear order. But when you descend into the quantum world, that order begins to lose its certainty. In the microscopic world, events do not always have the clear histories you expect. The state of a system is not always determined before it is observed. Before measurement, it exists in multiple possibilities at once, and this has direct consequences for how time is understood. A particle does not have a definite position until you measure its position. Before that, it is neither here nor there. It exists as a distribution of possibilities. When a measurement occurs, one outcome is selected. But what is striking is that the history leading to that outcome cannot always be told in a consistent way. In the classical view, the past determines the present. In the quantum world, the present can determine how the past is described, not by changing what happened, but by determining what can meaningfully be said to have happened. When you measure a quantum system, you are not merely collecting information, you are participating in shaping the state of the system. Before the measurement, there is no single history. After the measurement, the history is reconstructed so that it is consistent with the outcome. This is not a linguistic trick. It is a consequence of how quantum mathematics works. The equations describing the evolution of a system allow multiple possibilities to coexist. Only when a measurement interaction occurs does one possibility become actual. In this context, the past is no longer a fixed sequence of events that exists independently. It becomes part of a description that depends on measurement. You cannot state absolutely what happened unless you specify how you observed it. There are experiments that demonstrate this clearly. The way you choose to measure in the present affects what you can say about the system's behavior in the past. Not because you send signals backward in time, but because the microscopic past was not defined before it was constrained by measurement. In such situations, the question which path the particle took no longer has a single answer, not because of missing data, but because the question assumes a single history that does not exist. Quantum time is therefore unlike classical time. It is not a flow in which events are lined up in sequence. It is a structure in which possibilities are organized and only become history when the appropriate interaction occurs. This undermines the idea of a fixed past that exists independently of the present. At the quantum level, the past is not a sealed archive. It resembles a collection of possibilities that are selected when required. Not every level of reality operates this way. At large scales, continuous interactions with the environment cause histories to become stable very quickly. The macroscopic past appears solid and definite, but that solidity is the result of other possibilities being gradually eliminated. At the microscopic level, before that stabilization occurs, time remains flexible. Not flexible in an emotional sense, but in a physical, structural sense. A quantum system can be described without reference to an absolute moment in time. States are related to one another by correlations, not by the familiar temporal ordering. In some models, time does not even appear as a fundamental variable. States exist in relation to one another, and the sense of sequence emerges only when you choose a particular system as a reference. This raises a deep question. If, at the most fundamental level, time is not a fixed flow, then what creates the clear sense of a definite past that you experience every day? The answer lies in interaction. When quantum systems interact with their environment, alternative possibilities are progressively suppressed. One history becomes dominant. Other histories become inaccessible. This process creates what you call memory. Memory is not merely information stored in the brain. It is the physical trace of irreversible interactions at large scales. When these traces become dense enough, the past stabilizes. You cannot change it, not because of a prohibitive principle, but because no alternative possibilities remain. Quantum time shows that the certainty of the past is an emergent phenomenon, not a foundational one. It is the result of many possibilities being eliminated, not the original state of affairs. This changes how you see the relationship between past and present. The present is not shaped solely by the past. It also participates in determining which past becomes meaningful. There is no paradox here if you abandon classical intuition. The microscopic world does not follow a single, one-way story. It follows a structure of probabilities and correlations. Within that structure, time is no longer a sharp arrow. It is a network of relationships. Before and after are not always well defined until you ask a specific question. This does not allow you to change the past in the ordinary sense. You cannot go back and alter a macroscopic event, but it shows that the concept of the past, at the deepest level, is not as simple as you once believed. The past is not always a sealed collection of events. At the quantum level, it is a set of possibilities that once existed and only become history when constrained by interaction. Quantum time, therefore, does not deny your everyday experience. It explains why that experience is stable. Stability is a consequence of scale and interaction, not a universal property of time itself. When you recall an event, you are accessing a history that has been fixed by countless interactions. At that level, there is no room for ambiguity. But that ambiguity existed earlier, at a deeper layer. This suggests that time has multiple layers. At the surface, it is a clear flow. At depth, it is a probabilistic structure. Understanding this does not make the world unsettling. It makes the world more subtle. What you call what has happened is the result of a natural selection of possibilities. Quantum time does not erase the past. It shows how the past is formed. And when you look at that deeper level, the idea of a past fixed from the beginning is no longer necessary. The past becomes something constructed, not something pre-existing. In this picture, time does not merely flow. It is shaped by interaction, by measurement. And by the way, reality becomes large enough to stabilize itself. When the past is not necessarily fixed, the present does not lose its orientation. It reveals that the certainty you experience is the outcome of a deeper structure, one in which time is far more flexible than everyday intuition suggests. In every familiar experience, time always has a direction. You remember the past, but not the future. You can shatter a glass, but you never see the shards assemble themselves back together. Something in the world forces time to move in one direction. What is striking is that the fundamental laws of physics, at the microscopic level, do not impose this direction. They work almost the same if you reverse the direction of time. A collision between particles can run forward or backward in the equations without producing a contradiction. So where does the arrow of time come from? If not from the underlying laws, the answer lies in entropy. Not as an abstract concept, but as a quantity that describes how the world organizes itself. Entropy measures the degree of dispersion, the degree of disorder, or more precisely, the number of different ways a system can be arranged while still looking the same at the macroscopic level. A low entropy state is a very special state. There are very few ways to arrange the components of the system and still produce that state. A high entropy state is the opposite. There are countless different ways to reach it. When a glass is still intact, its molecules are arranged in a very specific structure. There are very few ways for the glass to exist intact. When the glass breaks, the pieces lie scattered. There are countless ways they can lie like that. Entropy increases. This does not require will or purpose. It is a statistical consequence. The natural world tends to move from less likely states to more likely states, simply because there are more ways for them to occur. The arrow of time, at the macroscopic level, is precisely the arrow of entropy. Time moves in the direction in which entropy increases, not because a law forbids entropy from decreasing, but because entropy increasing is overwhelmingly probable. In a closed system, entropy almost always increases, not because it cannot decrease, but because the probability of it decreasing on its own is extremely small, so small that you never observe it in practice. This creates a sense of irreversibility. When a process that increases entropy occurs, reversing it requires an arrangement so precise that it is practically impossible. You can mix milk into coffee very easily, but for the milk to separate itself from the coffee and return to the original state is something you never see, not because the molecules do not obey the laws, but because there are too many ways for them to mix and too few ways for them to separate exactly as before. Entropy, therefore, creates a preferred direction for time. It does not need a clock. It does not need an observer. It emerges from the statistics of possible states. This explains why you have memories of the past. Memory is a physical trace created as entropy increases. Storing information requires dissipating energy and increasing the entropy of the environment. You cannot remember the future because the future has not yet created traces. The past exists in the form of stable structures formed by irreversible processes. Your brain is a thermodynamic machine. Every thought, every memory is tied to energy consumption and an increase in entropy. Your experience of time having a direction is linked to your own physical activity. At a deeper level, this raises another question. If microscopic laws have no time direction, why did the universe begin in such a low entropy state? The early universe, according to observations, was highly ordered. Energy was distributed evenly. The structure was simple. Entropy was surprisingly low. This is precisely what allows entropy to increase later, creating the arrow of time. If the universe began in a high entropy state, there would be no preferred direction. Time would have no clear arrow. There would be no complex processes, no formation of structure, no memory. The existence of the arrow of time is therefore tightly bound to the initial conditions of the universe, not because the laws change, but because the starting point was special. As the universe expands, entropy has room to increase. Structures form, stars are born, planets appear, life arises. All of it relies on total entropy increasing. Even though local entropy can decrease, a star forming is a process that creates local order. But to do that, it must radiate heat into the environment, increasing overall entropy. Order is not free. It is paid for by disorder elsewhere. Life is the same. An organism maintains its structure by consuming energy and dumping entropy into the environment. It exists because of the arrow of time, not in spite of it. If entropy did not increase, there would be no irreversible processes, no history. Everything would fluctuate around states without creating a direction. There would be no before and after in the sense you experience. This shows that the arrow of time is not a fundamental property of the equations, but an emergent property of complex systems in a special universe. Time, at the deepest level, may be symmetric, but the world you live in is not. That world is built on an initial asymmetry, amplified by entropy. When you watch a film played backward, you recognize it immediately, not because the motion violates the laws, but because entropy decreases. Shards fly back into a glass. Smoke gathers into a flame. Those things are too special to happen naturally. Your perception of time is trained by entropy. You learn to distinguish past and future from traces. You do not need a clock to know the direction of time. You only need to look at the degree of order. Entropy, therefore, is not only a physical concept, it is a foundation for experience. It shapes memory, prediction, and the sense of passing. This does not make time subjective. It makes time tightly bound to the physical structure of the universe. The direction of time does not come from consciousness. Consciousness comes from the direction of time. As entropy increases, information about the past is dispersed into the environment. You cannot recover it. That irrecoverability creates the feeling of it having already passed. Time goes only one way, not because there is some pushing force. It goes one way because the universe is moving from a rare state to a more common state. The arrow of time is the arrow of probability. It indicates the direction the world is almost certain to go, even though in principle other directions are not forbidden. In everyday life, you do not see probability. You only see the outcome. That outcome repeats enough times to become obvious. Entropy explains why that obviousness exists. It shows that the direction of time is not a metaphysical mystery. It is a consequence of how states are counted. When you live in a universe where entropy increases, you live in a universe with a past and a future. And for that reason, time for you always moves forward. The universe has a history. That is no longer a hypothesis, but a conclusion drawn from observation. Galaxies are moving away from one another. Space is expanding. If you trace these motions backward, everything converges toward an extremely hot, extremely dense state. That is the moment called the Big Bang. But the Big Bang is not only the beginning of space and matter, it is also the starting point of the arrow of time. And it is precisely here that a profound mystery appears. According to thermodynamics, entropy tends to increase. If you go backward into the past, entropy must decrease. That means the early universe must have been in an extremely low entropy state. Not low in a relative sense, but low to an almost unimaginable degree. At first, this sounds contradictory. The early universe was very hot, very dense. Intuition often links heat and density with chaos. But in physics, that intuition is not entirely correct. Entropy does not depend only on temperature or density. It depends on how energy and matter are distributed, and on the number of microscopic configurations that correspond to that macroscopic state. The early universe, though hot and dense, was extraordinarily uniform. Energy was distributed almost the same everywhere. There were no large structures, no stars, no galaxies, no black holes. That uniformity is what matters. A universe that is uniform in a gravitational sense is a universe with low entropy. This sounds counterintuitive, but gravity plays a special role. For other forces, a uniform distribution is often a high entropy state. For gravity, a uniform distribution is instead a very special, very rare state. Gravity tends to clump matter together, configurations with structure, where matter concentrates into stars, galaxies, and especially black holes, have far higher entropy than an even distribution. The early universe, therefore, was a universe with low gravitational entropy. It is like a perfectly flat tabletop where every marble is placed evenly spaced. With just a small disturbance, the system will begin collapsing into clumps. Those disturbances did in fact exist. In the early universe, tiny quantum fluctuations appeared. They were extremely subtle differences in energy density. At first, they were almost negligible, but as the universe expanded and cooled, gravity amplified these small differences. Slightly denser regions pulled in more matter. Less dense regions became emptier. Over hundreds of millions of years, those tiny ripples became galaxies and clusters of galaxies. This process increases entropy, not because order disappears, but because the number of microscopic configurations that can exist increases dramatically. A universe with stars, galaxies, and black holes has far higher entropy than a uniform universe. Black holes, in particular, play a central role in this story. A black hole carries enormous entropy, proportional to the area of its event horizon. When matter falls into a black hole, the entropy of the universe increases by a very large amount. This shows that the universe is moving towards states of ever higher entropy, and that direction of motion is the direction of time you experience. But the key question remains: why did the universe begin in such a low entropy state? Why was the Big Bang not a state of maximal chaos, where everything was already in equilibrium from the start? If the universe began at high entropy, there would be no complex development, no formation of structure, no life, no observers to ask the question. This is what is called the past hypothesis, the assumption that the universe began in a very low entropy state. This hypothesis is not derived from the laws. It is introduced to explain the arrow of time. It does not explain why the initial entropy was low. It only asserts that it was. And precisely for that reason, it is one of the deepest mysteries in modern physics. Some approaches claim this is simply a fact with no deeper explanation. The universe began that way, and there is no reason behind it. Just as physical constants have specific values, low initial entropy is an initial condition. Other approaches try to find an explanation in a broader picture. One of them is the multiverse idea. In this framework, your universe is only one of many possible universes. Most universes in that ensemble may begin in a high entropy state and never develop anything noteworthy. But occasionally, rare fluctuations create a region of low entropy. That region can expand and become a universe like the one you live in. In this view, it is not surprising that you observe a universe with low initial entropy. Only such universes allow the existence of observers. This line of reasoning is not mechanistic. It is selective. You are not here because the universe is special. The universe seems special because you are here. However, this approach remains controversial. There is no direct way to test the existence of other universes. It sits at the boundary between physics and philosophy. Another direction tries to link low initial entropy to the nature of space-time itself. Perhaps the geometric structure of the early universe, or a very early period of inflation, placed the universe into a special state, inflation. The phase of extremely rapid expansion right after the Big Bang may have flattened the universe and suppressed certain forms of early disorder. But even inflation needs its own initial conditions. There is no complete solution at present. Each approach explains part of the picture, but leaves a deeper question behind. What is certain is that the arrow of time you experience is directly tied to the Big Bang. It is not a local property. It is a global property of the universe. When you remember the past, you are living in a universe where entropy used to be lower. When you face the future, you are moving along the path of increasing entropy. Time does not only flow in clocks or in consciousness. It is etched into the history of the universe. It begins not with a ticking rhythm, but with a special, rare state where gravitational order was astonishingly high. The Big Bang, therefore, is not only the beginning of everything, it is the origin of direction, the direction of time, the direction of memory, the direction of every story. And until the mystery of the initial entropy is answered, the arrow of time still carries a great question mark, suspended at the foundation of reality. When you look at a clock, you feel time flowing. 1 second follows the next. The present appears and then disappears, giving way to the next moment. This sensation is so strong that it seems impossible to doubt. Yet in modern physics, especially when space and time are considered together, that sensation is no longer self-evident. In relativity, there is no single present shared by the entire universe. What you call now depends on your motion and your position in space. Two people moving relative to one another will not agree on whether two events occur simultaneously. This is not due to limitations of measurement, but to the actual structure of space-time. When there is no absolute present, the concepts of past and future also become unstable. There is no single temporal plane dividing the universe into what has happened and what has not yet happened. Instead, the entire history of the universe exists as a complete four-dimensional structure. This perspective is called the block universe. In the block universe, space and time merge into a single entity. Every event, from the formation of the first atoms to the moment you are now experiencing, is a fixed point within that structure. The past does not disappear. The future is not something that does not yet exist. They are simply different regions of space-time. Like different locations on a map, none of them is not there simply because you have not reached it. In this framework, time does not flow. There is no river carrying you along. There are only events that exist. The sensation of passage arises because your consciousness experiences events in a particular order along your own world line. A world line is the sequence of events that constitute your existence in space-time, from your birth to every moment you have ever experienced. All are points on a continuous line. You do not move through time in a physical sense. You exist as a structure extended in time, in the block universe. You are not a three-dimensional object, existing only in the present moment and then vanishing. You are a four-dimensional entity. With your entire life stretched out as a shape in space-time, this view can feel alien, but it follows directly from relativity, not from purely philosophical speculation. When there is no absolute present, the idea that only this moment is real becomes difficult to defend. If two people cannot agree on what counts as the present, then the present cannot be an objective part of the universe. It is a concept tied to the observer. By contrast, space-time as a whole does not depend on the observer. It is the structure within which all observations take place. The block universe presents a static picture, but static does not mean lifeless. A film reel is static when placed on a table, yet when watched, you still experience motion, emotion, and story. In the block universe, the story of the universe exists in its entirety, but the fact that you experience it moment by moment remains real for you. The sensation of time passing does not vanish simply because the block universe is correct. It is no longer a fundamental property of the universe, but a property of experience. This raises deep questions about free will. If the entire future already exists within space-time, are your choices truly open? In the block universe view, what you will do in the future is already part of your world line. But that does not mean you are being forced from outside. Those choices still arise from you, from your own psychological and physical structure. The existence of an event says nothing about its cause. A future decision exists in space-time because you will make that decision, not the other way around. Still, the feeling that the future is already there can be unsettling. It challenges intuitions about openness and change. Some approaches attempt to reconcile this by distinguishing between existence and foreknowledge. The fact that the future exists does not mean you can know it before you experience it. From within your world line, the future remains uncertain in the block universe. Uncertainty is not a lack of existence, but a lack of information. You do not know what will happen because that information is not yet contained in the portion of consciousness you are currently experiencing. This perspective changes how you understand memory. Memory is not the past that has vanished, but present physical structures containing information about events located elsewhere in space-time. When you recall a memory, you are not pulling the past into the present. You are accessing a physical trace created by an event that occurred at another location along your world line. The past exists independently of memory. Memory is merely the bridge that allows you to access information about it. Likewise, predicting the future is not peering into a region that does not yet exist. It is inferring other parts of the space-time structure based on laws and available information. The block universe also blurs the boundary between actuality and possibility. In many theories, the entire space-time is fixed by initial conditions and laws. What happens is not the result of moment-by-moment updating, but of a complete structure. Yet this does not render your experience meaningless. Experience is precisely how that structure is lived from the inside. Each moment you feel is a local slice of space-time. You do not experience the entire block universe at once. You experience it in sequence, because your consciousness is organized that way. The feeling of the present is therefore a biological and cognitive phenomenon. It is not a physical plane sweeping across the universe. This explains why you always feel yourself to be in now. Even though there is no absolute now, your consciousness is always attached to a specific event on your world line, and that event is called the present. In the block universe, no moment is more privileged than another in terms of existence, yet each moment still matters to you, because it is where your consciousness resides. The coexistence of past, present, and future does not strip experience of its value. It simply places that experience within a broader context, where time is no longer a flow, but a structure. The block universe does not require you to feel time differently. It only shows that your feeling does not reflect the entirety of reality. You live in a universe where every moment is woven into space-time, and for that reason, your story is not swept away. It exists, whole and complete, as part of the structure of the universe. When familiar concepts of time are stripped away, what remains is not a closed answer, There is no final definition you are forced to accept. Instead, there is a shift in perspective. Time, as you experience it, may not be the objective flow of the universe. It may be an emergent structure, a way of organizing experience, a useful illusion. If that is true, a natural question arises. If time is not real in an absolute sense, then where does the meaning of life reside? In everyday life, you still wake up, still age, still remember and hope. Those experiences do not disappear simply because physics questions the nature of time. They still occur. They still leave traces. They still shape who you are. Meaning does not require an absolute timeline in order to exist. It only requires experience, and experience is undeniable. Even if the universe is a static structure in which all moments coexist, the fact that you live each moment remains real for you. Meaning does not lie in whether time flows or not. It lies in your presence at a particular point within that structure. In this view, life is not a sequence of moments swept away and lost. It is a complete form in spacetime. Each experience is an indelible part of that form. This offers a quiet kind of comfort. The past is not destroyed. It does not dissolve into nothingness. Moments that have passed still exist as regions of reality, no less real than the present. The people you once met, the words you once spoke, the emotions you once felt are not erased by time. They simply occupy a different location in space-time, no longer part of current experience, yet still part of reality. If time is an illusion, then loss is not erasure, but the loss of direct access. This does not make grief disappear, but it changes its nature. Loss no longer means non-existence. Likewise, the future is no longer an empty region yet to be formed. It is a part of the structure you have not yet experienced. From within experience, it remains open. You still do not know what will happen, and that not knowing is what creates the feeling of choice. In the block universe, the existence of the future does not negate freedom. Freedom does not lie in the future not existing, but in the fact that decisions arise from your own structure. You are the cause of what you do, regardless of where those actions reside in space-time. Meaning does not come from changing the structure of the universe. It comes from the fact that you are a part of that structure in a way that cannot be replaced. If time is an illusion, then meaning does not lie in extending it or resisting it. It lies in the density of experience, in how fully you are present when a moment is lived. A moment does not need to last long to have value. It only needs to be lived fully. Value is not proportional to duration, but to presence. This changes how you view urgency. If time is not truly flowing, then running out of time is not a cosmic fact, but a psychological state. You are not losing time. You are simply moving from one moment to another within experience. Anxiety about the future and fixation on the past both rest on the assumption that only the present is real. When that assumption weakens, attention shifts toward the experience that is unfolding, not because the present is the only moment that exists, but because it is the only moment you can directly experience. In this perspective, the practice of presence is not a vague spiritual suggestion. It is a logical consequence. If experience is where meaning resides, then being fully present with experience is the only way to touch meaning. Science does not give you a purpose for living, but it can remove illusions that cause you to lose purpose. When time is no longer an enemy that is slipping away, the pressure to keep up with life diminishes. You do not need to race against the universe. You are already part of it. Even if time is an emergent structure arising from entropy and consciousness, that does not make experience artificial. An illusion can still produce real emotions, real memories, and real consequences. Pain is real, even though it is generated by the nervous system. Love is real, even though it is tied to chemical processes. In the same way, the feeling of time passing is real in experience, even if it is not a fundamental property of the universe. Meaning does not require an absolute foundation. It requires relationship between you and the world, between experience and awareness, between what is happening and what is felt. If time is an illusion, then meaning does not lie in fighting that illusion. It lies in understanding it and living with it lucidly. You do not need an eternal timeline for life to have value. You only need experiences lived with attention and sincerity. In the vast picture of the universe, you may be small, But within the structure of experience, you are the center. Not in the sense that the universe revolves around you, but in the sense that all meaning passes through where you are present. If every moment exists, then no moment is meaningless. Every moment you live is a permanent part of the structure of reality. This does not require you to believe that time is an illusion. It only invites you to consider that, even if it is, life does not lose its meaning. On the contrary, it becomes fragile and precious in a different way, not because it is about to pass, but because it is an unrepeatable part of the whole. If time does not flow, then you are not being swept away. You are exactly where you belong in the universe, and living that position fully is where meaning resides.